Alright, this is the final section we are going to do in Chapter 12. Not the final section in this unit combination we're doing, but it is the final section in this particular chapter. And it's all about adding probabilities. So the last section we did was about multiplying them, and the key word there was and. So you were looking at the combination of two events happening. The key word for this particular lesson is going to be the word or. So you're looking at the choice between two things. So before we were looking at independent events and dependent events and things like that, but this time we're looking at what we call exclusive and inclusive. So first off, a couple of definitions. A simple event is an event that cannot be broken down into smaller events. So that would be just simply drawing a card or rolling a die. You cannot simplify that any further than just one particular event. A compound event is an event that consists of two or more simple events. So that would be rolling two dice or drawing two cards or maybe pulling two marbles out of a bag. Something like that. That's a compound event. And then mutually exclusive events are two events that cannot occur at the same time. So for instance, if I said I wanted to, in a deck of cards, I wanted to pick a heart or a black. Those cannot happen because none of the hearts are black and none of the black cards are hearts. So those are two mutually exclusive events. They cannot happen at the same time. If you choose a heart, you cannot choose a black card. If you choose a black card, you cannot choose a heart. So that's what it means to be mutually exclusive. So if you have two mutually exclusive events, and you want to find out what's the probability of both of those things happening, or either of those things happening, excuse me, not both, either of those things happening, then it's the sum of their probabilities. So it's no longer the multiplication of their probabilities, but the sum of their probabilities. So we'd have the probability of A or B. So you're only doing one event, but you're finding out what's the choice between this event or another event. So Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 soccer cards. If she selects a card at random from the stack, what is the probability that it is a baseball card or a soccer card? So it cannot be both baseball and a soccer card, but total we have 8, 5, 6. So we have 19 total cards. Okay, so there's 19 total cards. Now, we want to know what's the probability of picking baseball or soccer. So we want to know the probability of baseball or soccer. We're only picking one card. We're not picking two cards, we're just picking one card. What's the probability of getting either of these? Well, the probability of getting a baseball card is 8 out of 19. And we're simply going to add that to the probability of getting a soccer card, which is 6 out of 19. The combination of those two events, so looking at those together, would be a total probability of 14 out of 19. For me to be successful, I can pick either one of these, and together there are 14 combined baseball and soccer cards, so I have a 14 out of 19 chance of pulling one of those two types of cards. So very, very simple for now. Alright, next example. There are 7 girls and 6 boys on the junior class homecoming committee. A subcommittee of 4 people is being chosen at random to decide the theme for the class float. What is the probability that the subcommittee will have at least 2 girls? Now, this is a little different because this one, they're asking us at least 2 girls. So that means there could be, we know there are how many girls total? There's 7 girls. So it could have 2 girls, it could have 3 girls, or it could have 4 girls. It could be totally girls. So for this particular event, we need to figure out 3 different probabilities. So we're looking at there are 7 girls and 6 boys, and we want a committee of 4 people. Now again, it's going to be a combination because there is no president, vice president, secretary, and treasurer. It's just 4 people for the subcommittee. So what we have to do, so if I say the probability of at least 2 girls, that means I have the probability of 2 girls, 2 boys, plus the probability of 3 girls, 1 boy, plus the probability of 4 girls and 0 boys. So you have all 3 of those probabilities happening. So over here, the probability of this, now this is very similar to the example in the homework that we had where you were doing the cards actually, where we had the combination of choosing a couple of basketball cards with choosing a couple of baseball cards. It's the same idea. I have to do a combination of 7 choose 2, because I want any 2 girls of the 7, and then we multiply that by the combination of 6 choose 2 for all the boys. But we have 13 total people choosing 4 of them is my total option down here. So this will stay the same for all of them. This is the piece that's going to change. Because now I come down here and I say, okay, now I'm going to do a combination of 7 choose 3 girls times a combination of 6 choose 1 all over that same combination of 13 choosing 4. And then when I come next, we're going to have plus the combination of 7 choose 4. Now there's no combination of choosing no boys, so I could really just leave it there and then do 13 choose 4. So once you do all of these things, so I'm not going to go through necessarily all the intricacies of this because we've done this before and I think you guys kind of know what's going on here. But this is how you set it up. You have to do the combination of choosing 2 of the girls and 2 of the boys, then 3 of the girls and 1 of the boys, and then all 4 girls and no boys. Because when they say at least, there are 3 different things happening there. Now that total ends up being 112. It simplifies down, so it adds up and ends up simplifying down to 112 out of 143. So when you put it on your calculator and end up simplifying and everything else, the probability ends up being 112 out of 143. So make sure you take a moment to kind of get that in there, make sure you have all of that information copied down, and to really kind of look at what I did and how I set that up, because you will have to, because, I mean, again, we're building on these things, so what we did with combinations and permutations is still being applied to our probabilities. Now, we had mutually exclusive events, so now we have inclusive events. Inclusive events would be events that happen at the same time, or could happen at the same time. So it says can occur. Doesn't mean it has to, but it can occur. An example of this would be the probability of picking out of a deck of cards again, a king or a spade. There's one king that's also a spade, or one spade that's also a king. So that would be an inclusive event, because both of those things can happen at once. Now, there's 3 chances that it's going to be a king without being a spade, and there's 12 chances it's a spade without being a king. But there is that one piece of overlap. So to find the probability of this, what we do is it's the same thing. We take the probability of A plus the probability of B. However, you have to subtract away the probability of both. So for instance, if I looked at the probability, if we did the probability very quickly of that king or the spade. Excuse my poor drawing of a spade. Okay, so then we have the probability of getting a king would be 4 out of 52, correct? Then we have the probability of getting a spade would be 13 out of 52. Now I don't have to do combinations or anything because we're just choosing one card. However, there is one card that overlaps, that is both a king and a spade. So I'm going to subtract away 1 out of 52. Because you have 4 kings, 13 spades, but there's one card that's in both of those categories. So I have to subtract that away so you get rid of the overlap. So it ends up being 4 plus 13 is 17, minus 1 is going to be 16 out of 52. And you could reduce that down actually by 4. So we end up with 4 out of 13. So you have a 4 in 13 chance of getting a king or a spade out of the deck. So let's go ahead and look at some examples of this. This one was just kind of to help you out to see what that really meant to subtract that away. So this one says, suppose that of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that a student selected at random takes Spanish or biology? So this one's pretty straightforward. We want the probability of Spanish or biology. So the word or indicates addition. So I have the probability of Spanish, which is 550 out of 1,400, plus the probability of taking biology, which is 700 out of 1,400. Now, there are 400 that do both. So what I have to do, that's the overlap. So I have to subtract away 400 out of 1,400. So I end up getting 550 plus 7 is 1,250, minus 4 gives me 850 out of 1,400. And of course you could reduce that down and figure out what that is exactly, but I'm not going to worry about that for now. Alright, and that finishes out section 5 of chapter 12. So your homework there is 10 through 21, all of them. So make sure to, so that'll be the one that you're working on, well, for sophomores, technically that's the one you should be working on Friday during track and field day. Juniors, make sure you get that done at some point. But everyone needs to have that done by next week. And then there will be the last section, 13.1, over the weekend.